Hello everyone, my name is Nilis Denis and I'm the product manager for the Lunatic and Stunner instruments at Unchained Labs. I will be your moderator and I'm glad you are joining us today. We will have a Q&A session at the end of the presentation. To ask questions, all you have to do is click on Q&A in the Zoom navigation bar at the top or bottom of your screen and type your question. We will get to as many of them as we can. And now, I'd like to introduce Indira Carey, our awesome field application scientist for the Mid-Atlantic region in the US. Today, Indira will take us through how you can use Big Lunatic to accurately and rapidly determine the quality of nucleic acid samples. I'll hand it over to Indira now.
Thank you for the introduction, Nellis, and good morning, everyone. Thank you for joining us today. Taking absorbance measurements shouldn't be complicated. It shouldn't require a multitude of steps and mastery of complex equipment. I've certainly experienced my share of challenges with taking absorbance measurements. The amount of sample used, repeating readings because results were too variable, or having to dilute a sample multiple times. Add to the equation using a low throughput instrument or reading samples one by one, and that increases the time factor to get readings done. That's where the Big Lunatic comes in. Today, we'll discuss how the Lunatic can solve these problems for you and generate data you can trust. Here's what we'll walk through. We'll take a look at an overview of the Lunatic and its unique capabilities, very briefly touch on the basic principles of using absorbance readings for nucleic acid quantification, discuss data examples, and then wrap by looking at some additional features of the Lunatic. What is the Lunatic anyway? Our Big Lunatic is a full spectrum UV-Vis spec which requires only 2 microliters per sample. Big Lunatic can measure up to 96 samples at a time in just 5 minutes. That's done using our plates with a single microcuvette. Using our plates with 2 microcuvettes, which allow reading higher concentration samples, a full 96-well plate takes only 12 minutes. Our plates have a standard SPS footprint, so they're compatible with liquid handling robots. The analysis software, easy to use, and data is easily exported. We'll discuss some of the advanced analytics capabilities a little later in the presentation. Big Lunatic is the only system out there that can measure nucleic acids at high throughput and high concentration. The microfluidic circuit with 2 fixed path lengths, as you can see highlighted here, covers a wide dynamic range from 0.03 up to 275 OD. The unique microfluidic circuits molded into Lunatic plates and chips ensure that there's no cross-contamination or evaporation. Once the sample is loaded, it's pulled into this reservoir area by capillary action. Once the sample hits a hydrophobic point, it stops. At this step, the sample can sit for up to 2 hours before reading with no evaporation. After the plate's loaded into the instrument, the empty microcuvettes are read, and that removes any absorbance contribution from the plastic. A pump then applies a small vacuum, which moves the sample into the microcuvettes where the samples are read. Lunatic offers a wide concentration range for measurements, from 0.03 up to 275 OD. Here, we're showcasing that range using a dilution series with IgG. For double-stranded DNA, that translates into an upper limit of 13.8 mg per mil. With Lunatic, you can get high throughput capability using just 2 microliters of sample and across a wide concentration range without sample dilution. Lunatic offers superior accuracy and precision. As you can see from the dilution series shown here, this all translates to fast results using low sample volumes and data you can trust. In addition, the software offers powerful analytics to assess whether common contaminants are present in a sample. And we'll discuss this capability with data examples a little later in the presentation. Although for today's discussion, we're just focusing on nucleic acids, Lunatic can perform a variety of applications for proteins as well. Lunatic also offers a homebrew feature where you can custom design your application to suit your needs. Now let's take a look at some basics. Nucleic acids absorb UV light due to the ring structure of pyrimidines and purines. While there are slightly different absorbance wavelengths for each base, DNA and RNA polymers absorb maximally at 260 nanometers. The relationship between absorbance and concentration is expressed by the Beer-Lambert law, where C is the sample concentration, L is the path length of the measurement cuvette, and the extinction coefficient depends on the chemical makeup of the macromolecule. Sample concentration can be determined by a simple rearrangement of the equation, and that's shown here. For nucleic acids, an A260 reading of 1 taken using a cuvette with a path length of 10 millimeters translates into the concentration factors that are shown in the table. So calculating the concentration of a nucleic acid sample is done using the equation that's shown here. Lunatic software performs all of the necessary calculations and reports sample concentrations automatically. It's common practice to look at A260, A280, and A260, A230 ratios to assess sample purity. Shown here is a typical DNA spectrum. Now here's where DNA absorbs maximally at 260 nanometers. Proteins absorb over here at 280 nanometers. A low 260 to 80 ratio is an indication of protein contamination. Now, chaotropic salts and detergents like Triton, for example, absorb at 230 nanometers, and that's over in this region of the spectrum. So 260 to 30 ratios are impacted by these components. It's also interesting to note that protein bonds absorb at 230 nanometers, so low 260 to 30 ratios can also indicate protein contamination. Generally acceptable ratios are shown in the table. Assessing ratios for sample purity is standard, as I mentioned, and Lunatic software reports ratios automatically. Let's take a look at some data examples. Here we're looking at results from a sample of high-quality calf thymus DNA in TE buffer. This is a typical result for a clean sample. You can see the expected peak maximum at 260 nanometers, and the ratios are within an acceptable range. Note the accuracy and reproducibility. We're seeing nice low standard deviations and coefficients of variance for triplicate reads. In addition to choice of background correction method, Lunatic offers another advanced analytic capability called UNmix. What UNmix does is to identify the presence of common contaminants in the sample. The software analyzes the sample spectrum, then applies specific algorithms that deconvolute that information to reveal contaminants based on their characteristic spectra. Here's the result of a DNA sample analyzed with UNmix. The black line is the spectrum before deconvolution. UNmix identifies excess protein and salts, and that's shown by the blue line here. In the results table, the salt present is identified as guanidine thiocyanate. This sample would have to be repurified before using it in a downstream application. Next, let's take a look at how UNmix can help with problem samples. At first glance, this spectrum definitely looks odd. We're seeing high absorbance at 230 and then a poorly defined 260 nanometer peak. The background looks good. The A260, A280 ratio looks fine, but note that the 260 to 30 ratio is low. So let's use UNmix to dig a little deeper. Here we've recalculated the data using the UNmix application. Deconvolution of the spectrum shows the presence of impurities in blue and identifies that buffer components are present in the sample. Now, in this experiment, we actually spiked a calf thymus DNA sample with 2 millimolar EDTA to simulate a high EDTA sample. If you're working with a sample that looked like this one, repurifying to remove excess EDTA would be appropriate. One of our customers had an issue where they were getting higher DNA concentrations by absorbance measurements compared to when they used a fluorescent dye. So to troubleshoot this, they ran lambda DNA through their purification system and then compared the sample using Lunatic before and after purification. Now, they noticed that concentrations were similar, but the sample had significantly higher turbidity after purification, and that's shown on the right over here. The customer concluded the most likely source was bead carryover from the purification. Now, the UNmix app successfully deconvoluted the turbidity spectrum. In fact, the UNmix results were actually closer to their fluorescent dye results and could be done faster and cheaper without additional reagents and dilution steps. In this experiment, DNA was purified from tissue by lysing cells with DNazole and then precipitating the DNA with ethanol. That was followed by washing of the pellet and then solubilizing the DNA in water. Now the sample spectrum here is less than ideal. You can see it doesn't show a nicely defined peak at 260 nanometers. Turbidity was quite high in this sample, but also note the high concentration of guanidine thiocyanate. Now this could have happened because the washes weren't effective to remove the salt, so this sample should likely be repurified or the purification repeated with new starting material. And this experiment highlights the reproducibility of data that's generated using UNmix. A calf thymus DNA sample was spiked with calf liver RNA to simulate RNA contamination of a DNA sample, which can actually be a common issue. Now, UNmix was able to identify RNA as an impurity and report a concentration. Note the low standard deviation values in the table, and this was for quadruplicate reads. For a sample with high levels of RNA like this one, a RNase A treatment to remove the RNA could actually be done. A benefit of UNmix is that the additional information it provides allows you to quickly assess sample quality, and you can make a judgment call on whether the sample can be successful in downstream applications or whether it actually needs to be repurified or cleaned up further before you proceed. And this really saves both time and money. Let's look at some additional features of the Lunatic. Lunatic fits nicely all along the development pipeline from feasibility to manufacturing. We have IQ/OQ procedures available, and for labs doing manufacturing, quality assurance, quality control, Big Lunatic now also has a performance verification for new instruments. These tests meet the US Pharmacopoeia and European Pharmacopoeia guidelines for UV-Vis specs. The tests and all the calculations that are necessary are handled automatically by the software. Lunatic software is 21 CFR Part 11 compliant with full audit trail and electronic signature capabilities. We also offer a set of tryptophan standards that you can use to show accuracy, linearity, and precision on the Lunatic. In addition, for labs with high throughput needs, the plates used for Big Lunatic are compatible with liquid handling robots. We have a number of comprehensive and informative applications notes on the Lunatic webpage, so please do check these out to learn more about what can be done on the Lunatic. What we've shown you today is that obtaining nucleic acid concentrations doesn't have to be a time-consuming task using lots of precious sample. Big Lunatic offers high precision and accuracy using just 2 microliters of sample and across a wide concentration range without having to dilute samples. In addition, the advanced analytics can rapidly determine whether common contaminants are present in samples, which may impact performance in downstream applications. Big Lunatic offers all of this in a high-performance, easy-to-use system, meeting your needs today and into the future. And now we'll take questions.
Thank you, Indira, for that great overview of how easy it is to use Big Lunatic to determine the quality of nucleic acid samples. We have some great questions that have already been submitted. You can still ask a question by entering it in the Q&A section of your Zoom navigation bar. So Indira, the first question, can you clarify the measurement range for double-stranded DNA?
Sure, absolutely, Nellis. So the measurement range for double-stranded DNA is 1.5 nanograms per microliter up to approximately 13.8 micrograms per microliter.
Perfect, good question. Thank you. Second question is, do I have to read a full 96 well plate at a time, or can I just read a few samples? So
actually, you don't have to read a full 96 well plate at a time. It's actually possible to read just a few samples. So another option that we have is we offer strips which can be mounted onto a metal frame, and each strip has 2 columns of 8 wells. So that's another option that you have if you want to run fewer than a 96 well plate.
Okay, thank you. What are some of the contaminants that UNmix can identify in my sample?
So a couple of things, detergents, phenol, chaotropic salts are some of the common contaminants.
Okay, thank you. Fourth question, is it possible to reuse a well?
So actually wells cannot be reused, and the reason for that is because we actually take a reading of the empty well, and that makes sure that there's no contribution from the plastic. And so that's prior to the sample being read. So once the sample goes into the well, you actually can't reuse that well for another reading.
Okay, thank you. Can I run experiments with different buffers on one plate and still blank?
Yes, absolutely, you can. So there's a feature in the software that allows you to do sample grouping. So it is possible to read experiments where you're using different blanks and just group them accordingly in the software.
Okay, perfect, thank you. Approximately how long should it take to give a plate read of 96 samples?
So if you're using our plates with 1 microcuvette, a full 96 well plate to read will take just 5 minutes. If you're using our plates with the 2 microcuvettes, and so those allow us to get to the higher concentration ranges, approximately 12 minutes for a full plate.
Okay, perfect, thank you. Is it required to train or inform UNmix with impurity standards or solutions?
I think I'm interpreting that question to mean that you have to do some kind of calibrating in the system. So no, so basically what we have a library of spectra for common contaminants. And so when you read your sample in the UNmix app, it will actually compare your sample to the library of stored spectra is the best way that I can describe that. And so the information is all done automatically in the software. So there's no pre-calibrating or settings that you would have to do.
Okay, perfect, thank you. Next question. I don't know the concentrations on forehand, and samples can be of mixed concentrations, very low and very high concentrations. Which of the two range plates do I need to choose?
So what I would do is actually, if you have a range and you're not quite sure where to start, I would recommend starting with the plate with the 2 microcuvettes, because those actually cover the entire range, so that you'll be able to figure out, okay, which of my samples are falling into that lower range, which are higher, and you can actually capture all that and see all that with the plates with the 2 microcuvettes.
Okay, perfect, thank you. A similar question to that is why not use 1 plate instead of the 2?
So it has to do with the concentration range, the OD range that we're able to cover. And also built into that is the path length that we're working with on the plate. So the plate with 1 microcuvette has a 0.5 millimeter path length, and that allows us to capture an OD range that runs from 0.03 up to 40 OD quite effectively. And so with the plates that are 2 microcuvettes, we're dealing with 2 different path lengths, because that really helps us with the higher concentrations. So what we've got on those plates are path lengths of 0.1 and 0.7, and that works really well to help us to capture the higher ranges.
Okay, perfect, thank you. Next question. How well does the system handle viscous samples or air bubbles?
So that's actually a really good question. Those are good points. So viscosity will clearly have an impact on the microfluidics. So the upper limit of viscosity is actually 40 centipoise. I know I've worked with a couple of customers that actually measure viscosity of their samples. You do need to be careful with air bubbles. So we do recommend that when you're pipetting, to be sure not to push an air bubble into the microfluidics. So a couple of things that could help with that, and actually I was just talking to a customer about this yesterday, is at higher concentrations where you may be getting more viscosity, is doing reverse pipetting might be something that could help. I was chatting with somebody about that yesterday, actually.
Okay, thank you. Another question is, what is the concentration range for RNA?
So I'll give this in terms of the OD range. It would be the same 0.03 up to 275 OD. And if you do the standard concentration calculator where it's 40 microgram of RNA for the concentration factor, then you can kind of work out what that range is.
Okay, thank you. Final question, and then I think our time will be done. Can you introduce how to use Lunatic in NGS labs where it's filled with qubit?
So I think one of the things there is a good starting place is to start with your known concentrations of samples that you've gotten on the qubit, and just move over to the Lunatic and basically just start reading those samples that you've validated. To look at the Lunatic, I would actually probably start with the plates with the 2 microcuvettes, so that you've got the entire range, and just start doing comparisons. Use default settings on the Lunatic to help you to figure out and compare and validate between the 2 systems. Now clearly, between a fluorescent method and a UV absorbance method, you're going to have to look at concentration ranges. But if this is something that you would like to do and develop, we can definitely help you with that.
Okay, perfect. Thank you for answering all these great questions, Indira. The questions that we couldn't get to will be answered by email. And thank you for a great presentation as well. I also want to thank all of you who joined us live today. If you would like to have a deeper conversation with our team, please do get in touch with us. Our team would love to connect with you. Thank you again for attending our virtual seminar, and I hope you have a great rest of your day.